Today our systems of equations are changing though. Today we are solving systems of equations in 3 variables. If you don't have a calculator, you should probably grab one. Before we get into solving, let's talk about the answer format for a 3-variable system of equations. A 2-variable system of equations should have an answer that looks like what? A coordinate point. For a 3-variable system, it's also a coordinate point. But it's not a 2-dimensional coordinate point, which is what you're used to. When you're solving a 3-variable system of equations, you are no longer working in the 2-dimensional plane because there's not just 2 things varying. It's not just going up and down, left and right when you look at the graph. Now there's depth to it. You're looking at a 3-variable, a 3-dimensional graph. So when you talk about a coordinate point, for a 3D graph. Now, a coordinate point is also commonly called a what? An ordered pair. That's another form of what you've been told. For a 3D variable, it's a ordered triple. It's going to look something like X, Y, Z. Now that's if the variables are X, Y, and Z. You can use different variables in a system of equations. You can use different variables regardless of how many variables are in said system. Generally speaking, when you're working with an ordered pair or an ordered triple, the order that you put the letters in is alphabetical. If you are trying to solve a system of equations in 3 variables, you have to start with at least 3 equations. You can't solve it otherwise. So, generally speaking, our goal when solving these is to make it where we can take that 3-variable system and start to whittle it down. We do the same thing with a 2-variable system. We take the 2-variable system and try to whittle it down to only 1 variable that you're working with. 3 variables, you do the same. Now, generally, when it comes to working with a 3-variable system of equations, elimination is the better option. It's not the only option. You could still do substitution, but elimination tends to work better, except for in rare cases. And so we're going to stick with elimination. If you are trying to solve these, first thing you are going to do is you're going to have 3 equations. You're going to use 2 of them to eliminate 1 variable. After you've done that, use a different pair of equations to eliminate the same variable. By doing this, you're now going to have 2 equations that only have two variables in them. Which means the results of these two steps will give you a two-variable system. To solve using either elimination or substitution at that point. It'll get you to what you're familiar with. Once you've solved that two-variable system, you plug things back in to get the third answer, and you're good from there. And you should then have all three variables solved. So, we are going to solve the following. First example. 3x plus y minus z is equal to a negative 6. Now be careful with writing out your z's. Some of y'all write your z's and your 2's in a very similar manner, and it's gonna cause issues. So I recommend putting a line through the z's so that they don't get mixed up with 2's if you are a person who writes them in that way. If you write your 2's like this, then you're probably just fine. But be careful of that. 2x minus y plus 2z is equal to 8 is the second equation. And the third equation I'm going to give you is 4x plus y minus 3z is equal to a negative 21. Now, before I do anything with working with a three-variable system of equations, before I do any math, I come up with a game plan. I come up with a game plan of which variable it is going to be easiest to eliminate in multiple pairs. Now, sometimes that elimination, which is easiest, is going to be fairly easy to determine. On ones like this, which variable is going to disappear the most easily? Y, because they all have the same or opposite coefficients already. So y is going to be the easiest one to get rid of. But if y wasn't like that, if all of your variables, x, y, and z, were like the x's and like the z's, where they actually have some coefficients involved, between the x and the z, which one looks easiest to work with? Would it be easiest to eliminate x's, or would it be easiest to eliminate z's? Z's. X's. If I work with these two x's, I can multiply the second equation by negative 2, and that'll work pretty nicely. But is there a nice way to pair up these two without having to multiply both equations? No. Or these two? No. The z's, on the other hand, because one of them has a coefficient of 1, pairing up these two, I only have to multiply one equation by a number. Pairing up these two, the same thing. So z's would be the next best option. So generally speaking, make a game plan on which one's easiest to work with. In this one, level of difficulty is y is the easiest, z would be second easiest, x would be the hardest to eliminate. Granted, you don't need to know easiest, medium, and hard. You just need to know which one's the easiest. Okay, so I'm going to eliminate y's. I need to pick two different pairs of pairing up the equations. Do you notice that the second one's negative while the first and the last both have positive y's? Which means it's also easiest to pair up the second one with the first and with the second rather than pairing up these two. Because pairing up these two, if they're both positive, would mean I either had to subtract or multiply one of them by a -1 to make it work. So, that's kind of game planning going into it. I am going to pair up the second equation with the first and the second equation with the last. So, I'm going to start by taking those two off to the side. 3x plus y minus z equals -6. 2x minus y plus 2z is equal to 8. If it's a positive y and a negative y, I eliminate y's by adding or subtracting? Adding. That's why we like the positive and negative together. 3x plus 2x. 5x. Y plus a negative y. Cancels. That's the point. Negative z plus 2z. Positive z. -6 plus 8. 2. At this point, that equation I just got, that 5x plus z minus 2, I'm not going to do anything with it immediately. I hold it off to the side. I have to know what it is, but I'm going to come back to it. Before I can work with it, I need another equation in two variables. So again, I'm going back to my original 3 and I'm pairing up two of them. And I already kind of talked about it. It would be easiest to pair up these two because the positive and negative. And the key thing here, one of the most common mistakes I see, you have to make sure you're eliminating the same variable as what you did over here. Now in this one, because of the fact that all the y's had the ones and the negative ones in front of them, people don't tend to make the mistake as often. But in cases where there's numbers in front of them, always double check that you're eliminating the same variable. Okay, so I'm going to pull these two down here. 2x minus y plus 2z is equal to 8. 4x plus y minus 3z is equal to a -21. Make sure you copy them down correctly. Am I adding or subtracting to get the y's to disappear? Today's assignment's a book assignment.
Okay, thank you.
One's positive, one's negative. Add. 2x plus 4x is 6x. Negative y plus y cancels, that's the point. 2z plus a -3z is a -z. Equal to 8 plus a -21. -13. Once I'm down to two variables in the same, two equations in the same two variables, I bring those two together. You're going to find that on these problems, I write out a lot of arrows to make it easier to follow what I'm doing. You don't have to write the arrows. If you're a person who loses track of what you were doing, it might help. Now I've got a two-variable system of equations. I can either eliminate or I can change over to substitution if I prefer. Are these set up better for substitution or for elimination? They're set up for elimination. They're perfectly stacked. On top of that, the z's have opposite coefficients. So at this point, I can already eliminate the z's by adding. 5x plus 6x is 11x. Z plus a negative z cancels out. 2 plus a negative 13 is a negative 11. Divide by 11 and x is equal to a negative 1. If I was solving a system of equations in 2 variables, I wouldn't be done. If I'm solving a system of equations in 3 variables, I'm definitely not done. I need my other variables. I have x, I need y, I need z. To solve for the second variable, continue to work with your 2 variable equations. It's going to save you some headaches. Doesn't matter which one you work with, make a choice. I'm going to choose the first one. X is negative 1 plus z equal to 2. Negative 5 plus z equals 2. Z is equal to 7. Do not lose your answers along the way. I oftentimes use a highlighter just to make them stand out, and then I put my final answer when I box it, and I use the regular pen. You don't have to do that, that's just me. Okay, I've got 2 variables solved for, now I need the third one. Now I go back to one of my original 3 equations. And I plug these 2 back in. Doesn't matter which one you're plugging back into, you just got to make a choice. I'm continuing to solve for y, so it's probably easiest to use either the first or the second one because this one's got negative y, which means it's got a level of complexity added. Not much, but a little bit. So I'm going to use either the first one or the last one. The first one's got smaller numbers. 3, x is negative 1. Plus y minus z is 7 equal to negative 6. Negative 3 plus y minus 7 equals negative 6. From here, it's just your basic algebra. Y is equal to 4. These are my 3 variables. What does the coordinate point look like? X, Y, Z. Negative 1, 4, 7. I got 2 more examples, one of which is going to be a real fast one. The other one's the same length as this one. But otherwise, that's about it. X minus 3y plus 2z is equal to 18. Negative 2x plus 4y minus z is equal to negative 11. And negative 3x minus 2y plus 3z is equal to 14. first things first, you are better off starting by making a game plan on which variable looks easiest to eliminate twice. In this case, which variable is going to be our easiest one to work with? Z. X, you would have to multiply both equations by something regardless of which two you paired up. Y, you'd only have to multiply one equation here, but you'd have to multiply two regardless of the other pairing. Z, on the other hand, I can pair up these two, only have to multiply one equation, and I can pair up these two, only have to multiply one equation. So, I'm going to start with the top two. Top one already has the 2z, I'm not manipulating it. 5x minus 3y plus 2z equals 18. I'm leaving that equation alone. This one I'm pulling over and I'm multiplying it by 2. That way I have a negative 2 in front of the z. You are better off on this one and always making sure that they are opposites, one positive, one negative. Make sure that when you are multiplying by 2, you are putting this in parentheses and you're multiplying it by all of the pieces. 2 times negative 2x, negative 4x. 2 times 4y, 8y. 2 times negative z, negative 2z. Do not forget this piece. It's one of the most common things, and I saw a lot of you do it yesterday, is forget to multiply by the constant. 2 times a negative 11, negative 22. Do I add or subtract at this point? Add. If they're opposites, you add and they'll cancel. 5 plus a negative 4 is just a regular x. Negative 3y plus 8y is a positive 5y. 2z plus a negative 2z cancels, that's the point. Equals 18 plus a negative 22 is a negative 4. Which two would be best to pair up next? Bottom two. When I pull the top one, again, make sure you're trying to eliminate the correct variable. We eliminated z, we're going to continue to eliminate z. What am I going to multiply the top one by? To get the z's to match? 3. 3 times a negative 2x is a negative 6x. 3 times 4y is 12y. 3 times negative z is negative 3z. And do not forget the constant as well. 3 times negative 11, negative 33. This one I'm pulling as is because my z's now match. Negative 3x minus 2y plus 3z equal to 14. I'm hearing a lot from the same people, so I'm going to go to my name cards. I need to hear from more people. Oh, I don't need 3 names. Matea. Do you pronounce it Matea or Matea? Matea, that's what I thought. What would you tell me to do now? And what do we get? Beautiful. Y, but yeah. You got it. Jace, what do I do at this point? Yeah, put the two variable equations together. comes from there, this coming from right here, and you can manipulate them as you're pulling them over. I'm just not this time. You pull those two together and you're going to continue to solve. You can do substitution or you can do elimination. Let's say I wanted to stick with elimination because most of the time people tend to do better that way. Preston, I want to do elimination on this. What am I going to multiply by which equation to get some things to match up? First off, would it be easier to multiply something to get the x's to have the same number or the y's? Start there. Sure. And honestly, on this one, you could do either way. What would I have to multiply by this to get that? What number's hiding right here? Right there. Currently a 1. What do I multiply it by to get it to 9? Yeah, 9. You got this. Multiply it by 9. I'm going to draw an arrow because I'm going to write it immediately underneath so I don't have to rewrite everything. And now, what does this look like when I multiply it all by 9? 9 plus 45 plus 36. You got it. Sweet, I've got negative 9x, I've got a positive 9x. Those cancel out. Kaden, do they cancel out if I'm adding or subtracting? Adding. They're opposites, you add. Cancel. 10 plus 45 is 55. Y equals negative 19 plus a negative 36 happens to be a negative 55. Divide, and y is so close. Negative 1. Keep an eye on your positives and negatives. It's another thing that messed with people yesterday. I've got one variable. I need 2 more. Maddie, after I've got one variable, how can I find the second one?
Plug it into the equations you already have.
Which ones? I got a lot of equations.
I did x plus 5y equals negative 4.
That's the one I would have done too. Specifically, one of the 2 variable equations, doesn't matter which one, I definitely think that's the easiest option. X plus 5 times negative 1 equals negative 4. That's negative 5. X is 1. I have 2 variables. Now I need the third one. Isabella, how do I find the third one?
I'm going about it in a different way, but you just plug both of the variables into either one of the original equations.
Plug both of those into one of the original equations. There are other ways to do it, yes. This tends to be the easiest. I'm going to pick the first one. 5 times 1 minus 3 times negative 1 plus 2z equals 18. That's 5. That's plus 3. Eight plus 2z equals 18. 2z is equal to 10. Z ends up being 5. Maya, what's the final answer? One, negative 1, 5. Don't forget to put it in parentheses because it is an ordered triple. I was going to go through another problem. I think I'm just going to talk about it a little bit in that situation, because there was a reason I wanted to do a third example, but I think I can just talk about it, and that'll be better for time, and I think it'll still make sense. When it comes to three variable systems of equations, you still can have situations where there is no solution or infinitely many solutions. When doing this, though, it's not going to be as obvious as two variable systems, because when you're working with two variable systems, you're going to find out it's no solution or infinitely many solutions as soon as you start eliminating, because what's going to end up happening is an entire side of an equation is going to disappear, and the other side's either also going to turn into 0 or it's going to turn into a number. Differentiating between 0 equals 0 is infinitely many solutions, 0 equals 5 is no solution type of situation. The difference in three variable systems is because of the fact that there are three different equations to work with, and as you pair them up, you might not pair up the two that caused the conflict, because no solution or infinitely many solutions is always really a conflict of just two equations. You might, in your first two that you pair up, have it pop up. Or you might have it pop up in your second two that you've paired, or it might not show up until you've gotten it down to two variables. If you end up with a situation, and I'll show you the example I've done in the past, which this is the one I've done in the past. If, when you look at your three equations, if you notice that two of the equations appear to be like one is just a multiple of the other, do you notice that the first one, all of the numbers in front of those variables, if you triple them, you kind of get the same numbers in front of the third equation? If you notice that, pair up those two first, because those two are the ones that once you pair them up are causing conflict. So if you notice that, it's going to save you some work to pair up those ones first. Okay. But we are done with notes today. Your homework is back in the textbook. It is page 32. It is question numbers 1 through 7.